Okay, let's give this a go. Right, hi, I'm Ben. This is Master Computer Science, and today we will do an introduction to binary numbers. All computers work on binary numbers. What a binary number is, you've probably seen them previously. They look something like this. Okay, generally they come in sets of 8, which we call a byte. Each individual number is a bit. Each bit can be a 0 or a 1. The way I like to think about this is if we think of denary numbers or decimal numbers, the ones that humans use, if I put a number, let's say number 3, we would all look at that and go, that's the number 3. If I then put a 0 next to it, that would be the number 300. If I put a, let's say, a 7 there, that would be 307. The reason we know that is the position of the number matters. So, this is the ones column, this is the tens column, and this is the hundreds column. And if you've learned maths in this way, which I did, I know a lot of schools have changed recently, you look at that and you go, okay, so 1 times 7 is 7. 10 times 0 is 0. And 100 times 3 is 300. So if I add those numbers together, I get 307. Binary works in exactly the same way. However, binary does not have all the characters we have available to us. Decimal numbers have 9 symbols. You will all be familiar with all of these, hopefully. If not, this probably isn't the course for you. Okay, so we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can essentially represent 10 numbers without moving into the tens column. Okay. Binary is exactly the same. However, it only has 2 symbols. You can have a 0 or you can have a 1. You may also talk about these as off or on. Okay? Now, if we take that, well, if we look at the denary numbers again, each time we move up a place, we're timesing by 10. So 1 times 10 is 100. 10 times 10 is, 1 times 10 is 10. 10 times 10 is 100. 10 times 100 is 1,000. Okay, and it goes on infinitely like so. When we're doing binary, because we haven't got our 10 available symbols, we've only got 2, each time we move up, we are timesing by 2. So if we plug those in, if we put our positional numbers in place, we can say, well, we're going to start off with 1. So 1 in there, we can be 1 or 0. If we times by 2 to get into the next section, that's going to be 2. If we then times 2 by 2, we're going to get 4. 4 times 2 will be 8. 8 times 2 will be 16. 16 times 2 is 32. 32 times 2 is 64. And finally, 64 times 2 is 128. Okay. So whenever you do binary numbers, these numbers at the top stay the same. Just as in denary, we have 1, 10, 100, 1,000, 10,000, 100,000, and so on. These are always our first 8 column dividing numbers. You can go up, you can go 256, 512, 1,000 and 52, I think it is. I've got that wrong. Ignore that. Right. Okay. So let's see what number we've got here. So 1 times 1 gives us 1. 2 times 0 is 0. 4 times 1 is 4. 8 times 0 is 0. 16 times 1 is 16. 32 times 0 is 0. 64 times 1 is 64. And 128 times 0 is 0. I'm going to add those numbers together. Okay. Now, this isn't too difficult a number, but sometimes you might find that you're adding quite complicated numbers, especially when you're dealing with more than 8 bits, more than a byte. When that's the situation, what I tend to do is add together from the biggest numbers first and say, okay, 64 plus 16, or 64 plus 6 is 70, plus 10 is 80. Okay. Then I might add together the next two here. 4 plus 1 is 5. And then I can add all those together. And I can say, well, that is 85. So what we can say from this is 0, 1, 0, 1, 0, 1, 0, 1 can be converted to, or equals, 85. Okay, hope this has helped. Any questions, put in the comments. Thanks very much.